This is section 5.4. I can understand and identify end behavior. So we'll write the word behavior right here. And then a funny word coming up, asymptotes. Asymptotes. All right, A-S-Y-M-P-T-O-T-S. All right, now the warm-up here, it says what number is at the left end of the x-axis. So let's draw a little x-axis right here. And on the left end, that would be down here. Well, way down here on this end would be negative infinity. So we'll write negative infinity right there. And then at the right end, of course, that's going to be a positive infinity. And then I've got a little asterisk right here because it says over on this side, it says, is infinity, is that a number or more of a concept? Well, it really is more of a concept. Infinity is not a number. It's really the idea that you can go forever in that direction and the numbers get smaller and smaller and smaller, bigger in the negative direction, if you will. And then going in this direction, they get bigger and bigger and bigger in the positive direction. And then the next part says, what is the equation of a horizontal line? I know we've beat this to death. I'm hoping everybody's got this now. Horizontal lines would look like this, and they would be y equals a number. They're not x equals a number, they're y equals a number. And then take a look at this next sequence of symbols and see if you can figure out what it means. We've got a dollar sign right here, and then we've got a gas pump, and then we've got an arrow, and then we've got another dollar sign, and we've got a 3. So we've got $3 right here. We've got an arrow going from the dollar sign and the gas pump to that $3. Well, I'm not saying this is the only interpretation that you could have here, but one reasonable thing that we could come up with is, because this is a dollar sign, we're talking about the cost, so we could put cost of gas, okay, is, so it's getting close to, is close to $3. Now, there's no information on this about whether or not it's less than $3 and getting close to it from the lower side, or it's more than $3 and it's going down, or anything like that. But that would be a reasonable way to represent this long English sentence in just a couple of more mathematical or pictorial symbols here. Now, we already know some of the features of exponential functions, but in order to use some of the more advanced features of these, we're going to need some new vocabulary words. And both of these are pretty simple, but one of them has a pretty funny name, just as we've seen up above here. So let's talk about end behavior first. End behavior is a description of what type of values the function takes on near the ends of the x-axis. So near negative, whoops, make that look like an S, near the ends of the x-axis. So near negative infinity and near positive infinity. So we describe the left end of the x-axis like this, as x is negative infinity, or as it approaches negative infinity. And we describe the right end as x approaches positive infinity. And then we describe the function values this way. If the function values, if the y values are getting really close to the same number, okay, we say this, y is approaching this number right here. So if the values are approaching a single number, okay, and we use this other method right here, so y is approaching either plus or minus infinity if the values continue to increase, so that would be the plus infinity, or continue to decrease if it's going toward negative infinity. And then we'll also use function notation. Oops, this should have an f right there. Don't know where that went. So f approaches a number, or f of x approaches plus or minus infinity. So we can use y values, or we can use function values right there. Now, in math, we use the symbol. So I've already used this a couple times, but I want to make sure that we're clear on this. In math, we use this arrow symbol to take place of these words. It can say approaches, so as x approaches negative infinity, or we can say it's getting close to, or we can say goes to. So we could say as x goes to negative infinity, as x approaches positive infinity, as y gets close to this number right here, as y approaches plus or minus infinity, or as y gets close to plus or minus infinity, or as y goes to plus or minus infinity. All of those are different ways of saying the same thing. So if we had something like this, as x, then the arrow, and then the negative infinity, f of x, and then the arrow 0, here's how we'd read this. We'd say as x approaches negative infinity, f of x approaches 0, okay? Now, let's talk about an asymptote. An asymptote is a line that approximates, so write approximates the graph. Now, an asymptote is usually a line, but not always. And the asymptotes that we deal with in this class, they're a type of end behavior. They're a specific type of end behavior, and they will always be horizontal lines. horizontal lines. Now, they're not always going to be horizontal lines, but in this class, the end behavior that we deal with, they are going to be horizontal lines. And let me just talk for a second about the pronunciation of this word. Some people say asymptote or asymptote. They kind of have an E, a Z in there. I just say asymptote. So asymptote, asymptote. It's really a silent P in there, so it's asymptote. So kind of practice saying that word a couple times and you'll be in good shape. So I'm going to slide down here and we're going to take a look at this first example. We're going to use these examples today to just kind of illustrate these new vocabulary words that we've talked about and review some old ones. So on this one, we've got this line right here, and let's talk about the domain and the range. So the domain on this one, again, we'd squish this onto the x-axis. Everything would be covered, and again, we'll assume that there are arrows on the end there. So the domain is going to be from negative infinity to infinity. The range, we'd squish it onto the y-axis. Everything would be covered here, so this is going to be negative infinity to infinity. We're going to continue going down there and getting negative y values. We're going to continue going up here and getting positive y values. Let's practice finding function values. So f of 3, so this means we're given the x value and we want to find the y value, so we'd go over to 3, and then to get on the graph, we'd have to go down right here, so this is going to be negative 1. And then let's talk about the end behaviors. We normally go as x goes to negative infinity. We're going to do the left end first. So the further we go out in the left direction on that left end toward negative infinity, the bigger and bigger these function values get. They continue to go up. So the y values are going to go to positive infinity. And then let's check this direction. As we go toward positive infinity on the x-axis, the y values, the function values, continue to get smaller and smaller and smaller. So that's going to be negative infinity there. And then let's see, the x-intercept. The x-intercept is about right there. It crosses the x-axis. So we're going to say about, let's see, that would be about, say, 3/2, comma 0. And again, not perfect, but we're kind of close there. And then the y-intercept, let's see what the y-intercept would be. Y-intercept would be right here at 0, comma 1. And then is this increasing, decreasing, or constant? This is going to be decreasing because it's going down from left to right. And is there an asymptote? Is there a line that approximates the graph on the end? And the answer to that one is no, because the graph is a line. Okay, so we're just going to write none. There's not an asymptote. Okay, no need for an asymptote there. Now let's take a look at this next one. This right here should look familiar. That's kind of that classic exponential shape. So we had a linear shape up here, and then we've got an exponential right here. The domain, again, this goes forever in this direction and forever in that direction. Again, we'd continue going up and we'd have these function values that would slide down here onto the x-axis. So this is going to be from negative infinity to infinity, but the range is a little bit different. We don't have any y values down here. There are no part of the graph that we could squish onto the lower part of the y-axis, no part over here that we can squish over there. So it starts about right here. So we go from negative infinity, we go up here, we don't have any function values, and then starting about right there, so starting at 0. Whoops, let me just put a 0 here. And then we continue going up and up and up, so that's going to be from 0 to infinity. Now, this right here is an asymptote. It comes out here and it gets closer and closer and closer to the x-axis. So let's come down here and let's answer this question right now. The horizontal asymptote here would be y equals 0. It comes out here. It never actually touches the x-axis. It never actually has a function value of 0. It just gets closer and closer and closer to 0 like we've seen before in a few of our examples. So let's check the function value at negative 1. At negative 1, let's see, we're probably about, I don't know, maybe 0.7 or something like that. So let's put 0.7 there. And then the end behaviors, as x goes to negative infinity, what happens to those function values? Well, they get closer and closer to 0. So we say it approaches 0. And then as x approaches positive infinity, what happens to these values? They continue going up and up and up and up. So the function values approach positive infinity. And then the x-intercept, let's see what we've got here. Does this ever cross the x-axis? I mean, it kind of looks like it would come down here and touch, but remember, it doesn't. That's why we've got an asymptote. So we're going to put none. There is no x-intercept. And then the f-intercept, or in other words, the y-intercept would be right here. That's going to be 0, 1. Okay? Now, is it increasing or decreasing? Gosh, that's pretty easy. It's just kind of going like this and getting bigger and bigger and bigger. So this is going to be increasing. Okay, let's flip over and take a look at the other side. Same type of problem on example C here. So the domain, we're going to squish this onto the x-axis. We've got all of this covered here from negative infinity, and then we'd squish these up here. So this is going to be from negative infinity to positive infinity. The range, we do have values down here now that cover this part of the y-axis. These would squish over here, but then we run out of values up here. So starting way down here, we've got from negative infinity all the way up to, this looks like about 4, but then the question is that included? And remember, they're going to come up here. This is like an exponential graph somehow, similar to that last one that we looked at in example B. So they're going to get closer and closer and closer to that value of 4, but not actually reach it. Let's find the function value at 0. So that means we're going to go to 0 on the x-axis, and we would have to go up here. So that's going to be 3. And then let's talk end behavior. As x goes to negative infinity, they get closer and closer and closer to 4. And then as x goes to positive infinity, they get smaller and smaller and smaller, more negative if you want. So they would go to negative infinity. The x-intercept crosses about right there. Gosh, that looks like it's about perfect. That would be 2, 0. And the y-intercept, we actually answered this up above. That's right where it crosses, so that would be 0, 3. And then is this increasing or decreasing? Clearly the values are going to go down here, so this is a decreasing function. Now this last example's got a few graphs that have some unique properties, so let's go ahead and take a look at these. I'm going to shrink this down so we can see everything that we've got to include here. So this is what we've got here. It says we've got this graph A, and we've got this dot right here, and then a horizontal line, and then it takes this abrupt turn and then just continues going on in that linear fashion. And then this one kind of starts off flat over here, has this little swing to it, comes down here, and then flattens off again. Okay, so the domain on this one's not too bad. Remember, the domain are the x's, so they start off at, that looks like negative 10, and we've got a closed endpoint right there. And then no arrow on the end, so we'll assume that that goes on forever, so from negative 10 to infinity. And then the range, we don't have any answers for y values, for function values down here. They start at negative 3, and then they just continue going up and up and up and up and up. So this would be from negative 3, and we'll do a square bracket there, all the way to positive infinity. We need a function value for negative 9, so we're going to go to negative 9, and that would be, looks like negative 3. Okay, might be interesting if they said, hey, what's the function value at negative 11? At negative 11, there wouldn't be one because that's not in the domain. And then we'll look down here. As x goes to negative infinity, well, it doesn't really go to negative infinity. That's not part of what we've got here. So we're going to put NA because it doesn't go to negative infinity. The domain stops at negative 10. And then as x goes to positive infinity, so we can go out that direction, it gets larger and larger and larger. It goes like that. Now the x-intercept, it just asks for the x-intercept on this one. F-intercept there. So this is going to be, let's see, 2, 0. That's where it crosses the x-axis. And then the f-intercept, where does it cross right here? This would be 0, negative 2. The function value right there is negative 2. And then is this an increasing or decreasing or constant function? Well, this part is increasing, that's constant, so it's a little bit of both. I'm going to put that it's a mix of the two of those, depends on where you are, on what interval. And then the asymptote, there really is no asymptote on this because, again, we don't need a line to approximate the graph here. That is a line, and it stops right here, so there's nothing really going on there. So I'm going to put an NA on that one. And then let's take a look at this last one here. Domain and range, again, we'll assume that it extends forever in both directions. So this is going to be from negative infinity to infinity. And then this range is kind of interesting because we don't have any function values down here and we don't have any function values down here. So they really start about right here and they end about right there. So they go from negative 4 to 4. And remember, these, kind of like those exponential functions, they're just coming down here, and we'll assume, unless we're told otherwise, that they just get down there and they approach that. So this is going to be a round bracket there. And then it wants a function value at 4. I'm going to put a little equal sign on there. So at 4, that would be in between negative 3 and negative 4. So I'm going to put about 3.5. In fact, if we wanted to kind of emphasize that, I'm just going to put a little squiggly equal sign. That's the sign for approximately equals to. And then end behavior, as x goes to negative infinity, it gets really close to this horizontal line right there, which would be the line 4. And then as we go to positive infinity, it gets really, really close to negative 4, okay? And that type of behavior really describes our asymptote. So I'm going to come down here, and I'm going to say it's y equals 4 on the left end, down here negative infinity, and we're going to say y equals -4 on the right end over here at positive infinity, or as we tend toward positive infinity. And then we need an x-intercept. X-intercept looks like it's about right there, so that's going to be 1, 0. And the y-intercept, function intercept right about there, 0, 2. And then is this an increasing, decreasing, or constant function? Well, it's pretty flat here, but it is kind of continuing to go down, and then it breaks away from that asymptote, comes down here, and kind of hooks up with another one. So we're going to say that this is a decreasing function all the way along there. I'm going to slide down to the bottom here. Take just a second, look at the problems that we did today, do the self-assessment, and then we're going to take a look at problem 6 from the practice assignment. Okay, I've got the practice assignment up, and the instructions are at the top of the page. It says use the graph to fill in the information, write intercepts as ordered pairs, and it says some estimates may be needed. So let's slide down here and let's take a look at number 6. So there we are with number 6 right here. So we've got this classic shape right here. We've got this really steep curve right here, and if we wanted to, again, we could just assume that that continues up and on in this direction. Same thing over in that direction. So this is one of those exponential type shapes, and it says what's the domain on this one? So again, squish this all onto the x-axis. We'd have these points way up above that would come down here and shadow this part of the x-axis. Clearly we'd cover all of this on the positive side of the x-axis. So the domain's going to be from -infinity to infinity. The range, though, remember, we don't have any values down here. We don't really start getting any until we're right here at 3, and then we could go up as far as we want here. So this would be 3 to infinity. Always round around infinity, and remember, this is just going to come down here, and it's going to get closer and closer and closer to that horizontal line of y equals 3. So we're going to do a round bracket around that. And I'm going to jump immediately down here, and I'm going to write down, hey, that's our asymptote out here on the right end. So I'm going to write y equals 3 asymptote, and then in parentheses, I'm going to put that applies to the right end. You don't have to put that, but it's kind of a good idea. And then let's take a look at end behaviors. So as x approaches negative infinity, so as we go toward negative infinity, what's happening to the function values? Are they staying the same? Are they going up? Are they going down? Well, in this case, they're going up. They're kind of going off the charts right there. So that would be toward positive infinity. And then what happens as we go toward positive infinity in the x direction? So as x approaches positive infinity, go further and further out on the right end, these function values come down and they get closer and closer and closer. They just kind of level off right at 3, and that's why we've got our asymptote there. And then any x-intercepts, well, this doesn't come down and hit the x-axis at all, so we're going to put none right here. And then the y-intercept, gosh, it looks like that crosses right at 4, so we're going to put 0, 4. And then increasing, decreasing, or constant. Clearly, as we go from left to right, these function values are going down, so this is going to be a decreasing function. All right, good luck with the assignment.